Okay, so for problem 4, notice that you're given values for problem 4. I would avoid using the values until the very end if at all possible. Instead, I strongly encourage you to solve this problem first. Notice that there are no values in here. Notice that there's no values in here. I left everything in terms of L, in terms of W, in terms of P. The reason for this is that as soon as you plug in numbers, it's very hard to go backwards. It's very hard to go back and check your work to see if you've done something wrong. On an exam, for example, if you mess up something at the very beginning and you realize at the end that, wait a sec, I know that this has to be going to the right, but I'm getting a deflection to the left. And you have to go back and check every single step and carry every single number all the way through to see where you messed up. That will take a lot of time. If you go through this, you can see very quickly. Usually in this case, the worst thing that'll happen is that you were off by maybe a power or that you were off by a sign. And it's very easy to adjust those. It's not easy to adjust, like 176 gigapascals time, or like 200 gigapascals times, I don't know, like 15 kilonewtons times, 37.2 meters or something. It's absurd. It's very difficult to go backwards in a scenario like that. So keep this as general as possible. Don't plug numbers in until the very end. As before, I recommend you use superposition. Although it is not actually necessary for this problem because you can analyze, like this is not particularly complicated. I will say though that you have to take into account both deflection due to bending and deflection due to axial deformation. So that's the reason why you're given this axial term here. You do need to you should take it into account. And I think like if you just didn't need to take into account, the professor wouldn't have given you that information. In this case, I'm going to look at the two loads separately. Here. So I have this. This is going to cause, the only thing this is going to cause is moment in this arm and axial in this arm. I'm going to have zero shear in this arm, therefore, because I have no horizontal reaction here. If I have no horizontal reaction here and I don't have any loads applied on the horizontally on the vertical member, and there's no shear in the vertical member. With those two things in mind, that means that this has no moment, therefore this has no bending. Therefore this will remain straight. It does not have to remain vertical, that this can rotate, but it will remain straight. This top portion up here does have moment, therefore it will bend. And that bending I will use to find my, so if I look at my deflected shape, this is going to deflect something like, let me use a different color here. This is going to deflect this is going to deflect something like this. Right, this rotation here, this is going to rotate by some angle. You need to measure this. This is delta theta b. That's also going to be this angle here. I think based on what I heard in office hours, the professor did an example very similar to this. This was length L. Therefore, this length here, and we'll call that delta C horizontal, is equal to L delta theta B. I can find delta theta B using my moment area method, similar to what he did this, like almost the same thing, based on what I saw in people's notes. He did almost the same thing in class, so I'm not going to go over this here, just to save some time, but double check your notes to see how he actually found delta theta B. The axial load P generates tension in this member here. If I were to draw the deflected shape, do you guys agree that this would just stretch? It would just stretch, and then this whole thing would be shifted outwards. Alright, so this thing would cause some deflection there. I don't know if you guys remember back to your strength and materials course, that deflection, if this is P and this is 2L, PL on AE, this L should actually be 2L, right? I'm plugging this length into here. So my delta, let's call this delta BH, is equal to P times 2L divided by AE. Therefore, and you agree that there's no moment in this section? You can prove this yourself if you would like. There's no moment in this section, therefore, or there's no moment in this section, there's no moment in this section, therefore there's no bending in here, no bending in here. Therefore this will remain vertical. Therefore delta BH is equal to delta CH, and I'll call this 2, and this one 1. Therefore my delta CH is equal to delta CH1 plus delta CH2. And with that, this should be relatively straightforward. I think plugging all these numbers in shouldn't be too bad. And if you have any questions on this, please again email or stop by and see one of us. I generally prefer that you try and meet with us. I think meeting is just usually a lot more productive. It's a lot easier for us to see like what you're actually struggling with, and it's usually a lot faster communicating like in person. Like we can exchange back and forth in like 10 minutes what would take like 20 emails normally. Well, maybe 20 emails, maybe like 5 emails. But yeah, so please don't hesitate to see one of us. I know Professor Letchford has office hours on Wednesday. My office hours are on Tuesday. Hong's office hours are on Thursday. And I know Hong is very sad because very people apparently stop by his office hours, so please stop by and see Hong as well. He's getting a little bit lonely in his office. Other than that, I think that's about everything for this assignment. You can let us know if you have any questions.